What's up? All right, welcome back to this another live coding stream with Shelp. Today we'll be playing bingo with an octopus, aren't we? So I will really fast drop that accent because it's really embarrassing. Anyway, so as we read out loud yesterday, we're gonna play some bingo with a giant squid. The idea is to transform this input into bingo boards and then replay all of these random number drawings and then figure out which board won, basically. So that's the idea. No. So let's try to first do some fun parsing into a bingo board, maybe. Let's maybe that'll be a little bit easier. I'll say actual or input or something, which should be day 4. So I already took the liberty of copy pasting the input here. We'll read lines and then assert that solve 1. Well, actually it's day 4 dot solve 1 with the input dot is equal to apparently 4512. We'll import assert chase stuff, and then we don't yet have a day 4 class, which should be an object. That'll just have a fun solve 1, which takes in a list of strings and outputs an integer, and then we'll return 0 for now. Ooh, equal. Okie doke. And then the next, the actual input, we don't really know. What I want to do first maybe is make sure we've got the board up and running. So let's add a test for that. Maybe first we'll create an inner class bingo board tests. We'll do a nested one on that. And then we'll add a new test. Can parse a bingo board from a 5x5 string table or something. And we'll just use an example out of the test input, like this one looks nice. So if we'll assign input to this, and then what we can do is already do read lines on this. So we'll do join, no, not join, we'll do split by new line, and then we should get the same idea as here. So every line is a new list. And when I do assert, or maybe we'll parse that into a bingo board. So maybe we'll say parse to bingo board or something. We'll pass the input, and then we'll assume, we'll call this actual. We'll act as if we're creating a class. And then I want to perform some things on this. So I want to check that rows, for example, contains exactly all of these. So, and what should I do with this? Is this going to be lists? No, they're all going to be rows. So a row of this thing, and then maybe Ah, that's annoying. Like, it's because of these tabs, I think. Maybe that's why. Or because it's not tabs, in fact. Well, that sucks balls, because that means we have to do some trimming and stuff. Okay, can I do that smarter? Probably, yeah. Here they are in a normal. Voila. And then we'll multi-cursor on that. And then we can remain those multi-cursors. Paste here, and then we should get normal ones. Voila. So that's coolio. And then we have to do the same, I think, for columns. Because the problem is that we need to discover when those are like one line or one row. When you hit all of the numbers, then it should be you have bingo basically, but same goes for columns. So we always want to check for both rows and columns whether it's completed. Column. And these, they are a little bit different. Voila, we can paste and then just put some commas there. Then we'll have to do the same with the other ones. So that's the third column we're at now. So this is just how we're doing it right now. I mean, maybe we don't need that stuff. Goedemiddag. Alles goed? All right, here we go. And the last one. This just takes some setup, but I think it will be worth it. This way we can solve tinier problems in between, which will hopefully lead us to a better solution. Cool. We need a bingo board class and then a function, and then we'll also need row and columns, I guess. So maybe we'll start off with a data class bingo board. I don't know yet what it will have as things, but at least it should have rows and columns. So maybe we'll do that. Not private, so rows. It should be maybe just like that, rows, and columns, which should be columns. And I think I'm gonna make those two into type aliases. So then we'll need another data class for row, which should take 5. So maybe we can or a list. I'm not sure yet. Maybe a row can just be a value or something, or a list of values, list of ints. Ah, yeah, we can actually wait. We can do something like this: private val values, which is a list of integers, and then we say by well, actually, first we'll have to say that it's a list of integers, and then we'll say by a value. And now our row really is a list of ints, but we can put some extra stuff on there later. Well, for now, this probably will work, I think. And we'll need a different constructor for that as well. So where we get 5. So maybe let's add that one already, then we can make it compile a little bit better. So we've got a constructor for row, which takes in a var args of value int. And then we need to call this with values to list. As list. As list. Voila. Column is gonna look exactly the same. And then let's do some type aliases for rows and columns. List of rows then, and then columns is a list of, that's annoying. Column, that's really annoying. So, almost have it compiling. Now let's create our parsing function called parse to bingo board, which takes in, I mean, we can have that generated, in fact. Let's put it in here. No. Looks great. And we'll move it outside of the test class. And this one we can just return a new bingo board maybe. Of empty and empty. Something like this. Yeah, maybe we don't want these as, I mean, I'm quite sure I don't want these as regular values, because then they should be, I need to pass at least one, just a single list. A list of lists. And then deduce either rows or columns. I think I'm gonna deduce columns, make that into a computed property. It's taking a while to run. That's usually what happens in the, if you first run your tests, or run them for the first time. Oh, they're green. That's not, maybe I ran the wrong, I did run the wrong ones. Should have run the day 4 tests and I instead ran yesterday's tests. Voila. Okay, that's better, eh? Then, maybe what we can do is just pass rows maybe then. And then have columns be a computed property, where we transform those rows into, maybe that's for later. First, let's do, wait, let's keep that. And then the get should just return an empty list. And then we don't need to worry about that anymore. Okay, next part is to just pass along the rows. That should be easy enough because we already sort of have these. And it's this part, eh? So we can say return a new bingo word where we map input to integers, I think. So first of all, let's do all of them to integers, maybe, or we could. Yeah, I mean, we just need to create a new row. Of this string that we should then split. So this is a row line. So we want to transform that thing into a row. So a row line. And then before we can just do toInt on that, we need to split those up into based on a space, and then probably trim them or something. Map trim, so that unused spaces get removed, and then we'll probably have to do some cleanup. Yeah, maybe not trim, but we need to remove, in fact. So let's do filter. It is empty. So those I want wait, this is so not empty because filter keeps them, and then we'll map them to integer, and I think it's to int, and this is a single row. So we'll do that. And now we can just run our single test for that. See if that works. So I expect my actual.rows to work. Oh, it doesn't. Oh wait, maybe it does. Yeah, these seems like, yeah, it's the columns. Great. Now we can implement this part. Now I'm wondering why I wouldn't just put this into the constructor of a bingo board. No, we can do that later, refactor that stuff later. Okay, then the next part is to do the transpose thing, I guess. So we'll have to, for every row, grab the, for every row, grab the ones at the same index and then join those. So it's a mapping function, might be a flat map, but we'll see. So rows, I think we can do map indexed, I'm not really sure. Voila. I think we need to do flat map probably, yeah. So for every row, I think I can't do it like this because I need the next row as well for this. The other thing I could do is say, okay, I think I'm gonna have to do something that takes a little bit more space. I can't do it in one line from the get-go apparently, because I'm too stupid. It happens, it's okay. we can probably refactor it into a smarter solution later. So my idea was now to make a range from 1 to rows dot length or size, yeah, because it's a for each on that, I guess. Then we'll get sort of get an index. And then what I can do is create a new list outside of here. Temp columns or something, which is a mutable list of integers. And then I can say temples add and only get the first elements of every row. So that would be rows map. So row at. We should do for in each index, I guess. Is it at all, maybe? What does this return? This is incorrect then, I guess. Because this should be a list of lists. Then this could be it, I think. And then we just return temples to list. I need to columns. Yeah, I'm really quite stupid. So this is a column, and then I need to create a new column of this part, and then we can just return temples. Okay. Yeah. This doesn't change. It's just a mutable list. Okay. Problem? I never use it. Then I might have made a mistake, eh? Yeah, Damn. Gotta love it when you can't figure out your own code anymore. So I'm saying loop for 5 times, basically. And then 5 times I want you to map the rows and grab all of the values at this index. Yeah, makes sense, I think. But then indeed, why do I need this. Oh yeah, it's not a row in fact. It's just a value, and I'm not doing anything with that. So instead of doing this, maybe what I could do is do from 0, or we'll do index -1 here. And then instead of calling it index, let's call it value or something. And then we can get rid of the for each index, just call it for each. Shouldn't you use map there? Probably. Here? Well, let's make it work first. I tried writing it as map first, but I couldn't figure out how. It's green though. Ah yeah, we could map these. Yeah, then I could actually, you're right. If I map a value, then we don't need to add, we can just return this, and that is that, I think. So we can return that part. Let's see if that's indeed the case. Yay! Thank you for the suggestion. Now we can one-line it. Oh. Isa. Cheers, TV Josh. All right, so we can parse a bingo board. Hooray. Next part is, yeah, we sort of want to keep which values have been ticked off. So instead of keeping just regular integers, what I think I want to do is map these to not just integers, but as, how would you say that? Do they numbers? No, you draw numbers. There are no winners, but are marked. Maybe markable number or something, I don't know. Yeah, marked numbers, okay. Let's call them markable numbers then. So instead of having just integers here, let's call them markable numbers. Wait, unmarkable number, list of, and we'll have to do the same for columns. I think we can keep the constructor of having multiple integers here. We just need to then map those into markable numbers. And then initially, when you create them, they're all empty. Yeah, we'll see what happens with that. So let's declare a new type called markable number, and it should contain an actual value, like, or the number, which is an integer, and then it should probably keep maybe just a boolean or something, whether it's marked or not. And initially it's false. That should be useful. And then we just need to map these. Create new markable numbers with it. And we'll have to do the same with columns. And what's the matter here? Creating a row. we do have a constructor that takes a var arg, but here to parse it, apparently we're using this part, like actual integers. So either I should try to turn this thing into var args, but I'm not really sure how you do that. To array? To int array? And then I believe you need to like put a star in front of it. Yeah, okay. So this is saying expand this array as a variable arguments thing. So it's a bit tricky, but I want to use this constructor basically. That's why I had to do it like that. Let's see if it still works. Now I can't really test that, or my test doesn't take into account that they're all unmarked basically, but yeah, we will see. Ooh. Thanks, sorry for the explosion of sound there. Maybe I can turn down the volume a bit. And thank you for following TV Josh. If you're also interested, you can join the Discord and hang out with other people offline, off stream, let's say. Cool, so we've got a bingo board, that's great. Maybe the next thing we should do now is if we pass, we should probably do a function to this bingo board here. So create a new test, marking a number that doesn't exist, does nothing to the bingo board. Then what we can also do is, of course, marking a number that does exist. Marks the matching number on the bingo board. And then what can we do? Maybe we can put this thing as a board 1 or something. We'll call it first bingo board input or something. And we can make a constant out of that, huh? We made a bit of a typo there. I thought we could make that thing into a constant, but that's fine. If we can't, it's fine. Let's inline this maybe. And then what that means is we can do this, get a bingo board, and then when we say assert, well, what we'll do is actual, and then mark or find and mark or something, which number does not exist. Is there a limit to the integers? 15 does exist, 16, 17, 18. 18 does not exist. Let's do that one. Oh, wait, 18 does exist. 19 does exist as well. 20, 21, 22, 23, 24. I think it's just a 1 to 24 thing, so 25 shouldn't exist then, I guess. Yeah. Cool, cool. Find and mark 25. And then I'm not really sure what I want. Do we want to mutate the bingo board? Or do we want to have a new bingo board returned? That I'm not really sure about. But let's try to do it first without making bingo board immutable. Although we'll have to loop on them. Tja. Updated bingo board, I guess, which is a bingo board. Male. And then we should assert that there are no changes, so that actual, no, this is now actual, the updated bingo board, in fact, is equal to starting bingo board or something. This becomes actual then. So, and now we need this function. We'll do the same here, and then with a number that does exist, like 24. And now number 24 should be marked. So it's a bit annoying that we have to, or we should check the equality of that thing by looking at the bingo board itself, where I really want to, yeah, here it makes sense, but here I want to just check that 24 was marked. So maybe I'll just do find 24. So like this. Actual not find 24 is equal to a markable number that has 24 and is marked. Something like that. Okay, let's create this function. Number, we'll call this. It's an int. It should return a new bingo board. Return this. Okay, and then our find function should be a bingo board. No, it should be a markable number. We don't need the generic type. Yeah, and then basically we should return rows find number maybe, and then we'll implement this as an extension function. I want to implement that on the rows. And this should just do a filter where it dot value our number oh wait, incorrect. It should be on the row. Ah, oui, am I? I guess. I don't necessarily want to filter the rows. I just want to for each them or something. And then if it find number. Oh, it's a private shit. Number equals number to find. Maybe what I should do is turn this into a nullable thing, because you might not find it. So this find should return, yeah, voila, a question mark. So if you found it, then return it, and otherwise that's about it. So what we can do is attempt or something. I don't really know how to call this thing. If attempt is not null, then we want to return not the for each, but return the attempt. And else I want to continue, so that would be here, return null. Here we are shadowing, I think. This will be a markable number, I think. This is a first, I think. So maybe it should be first with nay, it's still incorrect. Because first is gonna return a row instead of my number. Is this where you can do take or something? No. Whatevs. Okay, this should return the number then, at least. If you find it. And now we should also try to do this. So here this turns into find with the number. Aye. And now I want to change this one, but I don't think I can because... Or can I? We can try. Huh? Mark. And Mark is not a name. Oh, hi Mark. But Mark should do marked equals true. Oh yeah, we shouldn't probably do this. Maybe if, you know, it's still a val. Okay then, let's mutate this. Nice. Then now I made a choice of making everything mutable. Oh yeah, so try to do that. And don't return anything. And then I guess we should do the same thing here. So it does. I mean, this is a silly test now. Huh? Don't change anything if you didn't find anything. Let's get rid of it. So let's try running this test. Olé, this works. Great. And then the last thing I wanted to check is what was it again? Bingo or something. There's a bingo when a bingo board has one row completely marked, has a completely marked row, and also when you have a completely marked column. So again, if we start from this one and we starting board, find and mark these. Maybe what I can do is I can do rows, first row for each number. Yeah, so now it's a bit dirty because I can just change the state outside of the bingo board now, of course. Let's assume, so these are all of the numbers of the first row, and then I want my bingo board. I don't know if you can do this, in fact. You should be able to do it, because for each creates a new list, maybe? I'm not really sure. Mark, find and mark, number. Number. Maybe this will do a destructuring thing then. Can you do that? No, you can't. Oh, domme. Ah, it's fine. So when that happens, maybe we can return that there was a bingo or something when we do find and mark. Bingo? So now we've got true, false, or Maybe we should just type alias or something, I don't know. Let's do that instead. And now I think I don't want to do it like this anymore. I want to take this row here. Okay, and then I want to transform all of these basically. Voila. And it's at the last one here that it should be true. So these should all is false. And then here it should be is true. Okay, let's run it. Okay. So now instead of always returning false, return we have bingo. Check bingo. I don't know. Let's make a new function, check bingo, which returns a boolean. And then this one should just check. In fact, it should return a bingo or not. So let's loop all of the rows and then I guess we can do that with if we do rows.any. If any of them has bingo or something like that. That doesn't exist yet. I wonder if we can. Function declaration must have a name. But bingo is a boolean. Okay. It's still not compiling. Does any any returns a boolean? Allez, I don't understand. Here we just need to check all, so return value. So these are all the numbers. Maybe I should rename that value thing. Call it numbers. So return numbers, all are marked. We have to do the same for a column. So, and then here I don't know what the hell is going on. Oh. That'll happen sometimes, eh? There we go. Now we can run it. Isa. I wonder if you can delete this. Nee. Okay. Yeah, so next part is do the same for columns basically. And then I want these, or I could try like this, because they're already in a column. So that's the first column. And then run all of the tests. Cool. Then our check bingo should resort to either any of the rows have bingo or any of the columns has bingo. Voila. Run the tests. Should be green. Yep. That's nice. That's nice. Oh yeah. Cool. Now what we should do is make sure that we can parse the actual input into both a board and a list of numbers, but that shouldn't be too difficult. We can probably just do that in one go, in fact. Okay, so if we do solve one, yeah, maybe we should now move all of this crap to production files. And try to solve it. So our first, what do you call that? Take first or something. The first row is our random, how do you say that? Numbers that are being drawn. So drawn randomly, drawn numbers. Let's make that into a list of integers. And then we'll need to map that one. I not map, but split, because it's a string, right? Yeah. Sorry, what? Yeah. Wait. A list containing the first n elements yeah, I mean, then what we should probably just do is this, and then split this one using commas, I think, and then map those to integers. Let's see. Yeah, they're all commas. Okay, nice. And then we just drop the first two. And then we split with empty lines or something like that. And then those will be our boards. So then we'll have a list of strings, or a list of strings, really. Maybe we can do our trick that we did yesterday and do this in a sketch file. Not what I wanted to do, but this should be the input. I don't know if I can use input here. Seems like I can. Okay, nice. So if I then drop the first two and then split them. Okay, I guess I can't do it because things split based on new line. Yeah, we need to first split them by new line, and that's basically our function that returns a bunch of lists as strings. Then I want to drop the first two lines of that. Yeah. I wonder what this thing does then. So if, let's see what comes out of this, huh? Nee? So we've got all of these rows, and then when we see 19 here, then there's an empty one. Huh? So an empty string basically signifies a new oh gee, how are we gonna do that? The start of a new board. We could always do windowed, of course, of 5 because they're 5 long. Ah, wait. When we do drop 2, then we can also get rid of the blanks. And then we'll window them. Young. So again, I feel like this is the way we want to do it, in fact. Okay, so these are the drawn numbers, and then we'll want our bingo boards, which is a list of bingo boards. And these we'll get by doing input drop to get rid of the blanks. Then return them as windowed, and then for each we'll map these by creating a new bingo board of it, I think, eh? Nee? Yeah, it should be a list of strings, allee. Not bingo board, but parse to bingo board. Voila. Okay, and now what we need to do is for every randomly drawn number, I also want to bingo board map saying first of all, find and mark with number, and then if this returns true, then that's the bingo board that won, basically. So let's try that. So far winning board. So if this returns bingo, then a winning board. Let's set it to this. Well, actually, no, we don't need to do that. We don't need to keep it, because then we can just go straight into the solution, which was the entire top row is marked. The score can be calculated. Start by finding the sum of all unmarked numbers on that board. So it's basically saying find unmarked. Which just returns a bunch of numbers, and we sum those. I think that's just this. Sum of unmarked. And then we need to return sum of unmarked times the number. And we're good. So we don't need to do this either. Now we just need this part, find unmarked. Find unmarked. We can just do that on rows as well. So return all of the rows, find unmarked. Okay. So on a list of a row, so really on rows, we had that thing here as well. Huh? That is for each, we just want to map it. So maybe that will just turn into a flat map of every row. Actually, it's not find, it's just get. Get unmarked. And then on row, we'll have a get unmarked function, which returns a list of integers. And then we'll just do return numbers dot filter it dot unmarked. Oh yeah, and then just map them. IntelliJ is gonna suggest us to change that into a filter map. It's not. Huh. Could have sworn there was something like that. Aight. This I still want to change. And then just say... Voila, and then we'll just use unmarked here. Or was it with a not marked in a row here? Okay, then we're returning. Oh, what the hell? I thought that was this one. Oh, otherwise, so I guess if you've got no randomly drawn numbers. Maybe we can just throw legal states. There were no randomly drawn numbers or bingo boards. All right, let's run our day 4 tests for the actual input here. Oui. We could try doing this in our Scratch file. Seeing what that does. Yeah, so first we need to do that. Maybe this part isn't lying. Oh, it automatically skips the blanks or something? No, it puts a blank at the end. Ah, that's why. Yeah, no, I want to not include, because here we've got 1, 2, 3, 4, and then an empty line. That's not what I wanted. Here we've got a 1, 2, 3, 4, 5. I don't understand why. Here it does stop at 19, but then here it starts with 8, 8 to 23. That's this one. Oh shit. So I want to do size 5, but also step 5, I guess. Yeah. And then I really do want to drop. Filter not is blank. This will probably be better, eh? 3.15.0. Yeah. Okay, nice. And then that one is 14.21. 14.21. Okay, nice. So this is it. Oh, this is why I only kept the ones that were blank. I'm such an idiot. Voila. Let's rerun our tests. Yay. Then I want a test for the actual input. Actual input should return, I don't know yet. We'll keep it at 4, 5, 12. Let's see if that's indeed the correct answer. Woohoo! All right, let's commit. And then it might be wise to try a different strategy. Let the giant squid win. You aren't sure how many bingo boards a giant squid could play at once, so rather than waste time counting its arms, the safe thing to do is to figure out which board will win last and choose that one. That way, no matter which board it picks, it will win for sure. In the above example, the second board is the last to win, which happens after 13 is eventually called and its middle column is completely marked. If you were to keep playing until this point, the second board would have a sum of unmarked numbers equal to 148, and then it's that one. Okay. Not 4, 5, 12, but 1, 9, blah, blah. Okay, so instead of making sure that we've got the first one, we should just mark those bingo boards as one or not or something like that. And then find the last one, because they're in order anyway, are they? Yeah, if I add them to a list of winning boards, then yes, I guess. Okay. Mutable list of bingo boards. So instead of doing return, so once you find and mark and it's true, then add it to winning boards. I mean, we could do the same here. Just get all of the boards and get the first one. Add bingo board. And then at the last part here, we should just return last. And then on this board, we need to do this logic here. Oh, fuck. So I need to return and the number and the board, so it's not just this. So let's do to number. And now we've got a pair of bingo boards and their winning number, which is an integer. So, and then just find the last one, and then map that thing. So let board number if you want to destructure it needs to be in parentheses. We'll do board dot find unmarked, sum those and times it with the number, and then that should be it. And now I think what I want to do first is rewrite this first solution in the same style as so. So return. And this should return a list of pairs of bingo boards and integers. And then solve one is gonna be first instead of last. So let's try running our first tests. Oh yeah, we can just run them all in fact. There's something wrong, apparently. I think the issue is that once you it's an issue with the mutability of the bingo board, I think. So what will happen is we continue finding and marking numbers on a bingo board after it's been won. So maybe what we should try and do is freeze its state or something. We could do that. Oh. Maybe that's easiest. Otherwise I have to change a bit on how we are keeping these, like deep copy them or some stuff like that. I think I'm gonna try and do that. So if check bingo is true, then freeze board or something. We could do that a little bit smarter, I think. So if we inline this, and I would say also conditionally freeze board. Okay, private freeze board. How the hell are we gonna do that? Freeze a bingo board. Oh, I've got an idea. If, well, no, we just said this dot bingo equals bingo. Or we can say frozen here, yeah. It's much better. Private frozen. It's a boolean, or else it should be a variable. Yeah. Let's set it to false initially. And now what we can do is wrap all of our functions here and return defaults or something if the board is frozen. So instead of writing it like that, we should write it like when not frozen or something. And then this is going to be another private function. When not frozen, and it should contain a block you want to execute. And I guess can we do that actually? We just say if not frozen, execute block, else frozen default, which should be a T, else will return frozen default. And now this, of course, needs to go first, otherwise you cannot. Find and mark. I guess this will always be true. And now what? Oh yeah, I need to say that you should return T, of course. Yeah. And same for this thing. When not frozen, find. I don't know what we should return here as a default. I mean, this is not doing anything, right? We don't necessarily need to wanna change that. If this is the only mutating function, I guess, that we have, so this should already be enough, I think. So now find and mark for a number won't do anything because we'll just always return true. But shit. So now if we always return true in our solution here, and this thing returns true, we'll add this board again with this number. Okay, so now, yeah, at least we're not muting the board anymore. So now we just need to solve the fact that this might get updated or not. Do we want to add an identifier to the board or something? Let's do that. Or we could auto-generate it, might be easier. Then we don't have to mess too much. Okay, let's do... Arsa. Okay, some more errors. What the fuck is your problem? Oh, yeah. Okay. Then we need to, instead of keeping a list, I want a map or something. Map. And then not of pairs, but then of board IDs or something. So UUIDs and pairs. And then what I should do is say put if absent with bingo board.id and then the pair. And then we are really not changing bingo boards anymore. And this should just return values. Ne? Mayo. To list. Okay, now let's rerun our tests. Phew. Yeah, so the example input we have fixed, so both of these are working. Oh yeah, actually, this should be like that. And now, oh, lay fucker. Oh yeah, it's not, this shouldn't be 4512, eh? Voila. Let's rerun it. And then this is probably incorrect now, of course. But we're getting the actual one. Oh, so that's hopefully the correct answer. Let's find out. OMG, we did it. Nice. Okay, let's. Let's look at our code. So these are all the tests. Then if you go to our code, solving one was just really trying to solve in general, and then getting the first board, and then finding all of the unmarked numbers, sum them and multiply them with a number that was, maybe this is a winning number. Let's just do winning number, voila. And then for solve 2, we should take the last one. Do the same thing here. And then how do we solve? Well, first we need to parse a little bit. We'll parse first the randomly drawn numbers. Then we'll parse the rest of the things into bingo boards. And then we're setting up a new map of winning boards. And we'll just loop over all of the randomly drawn numbers. And then we'll have every board find and mark that number if it works, or if it finds it or not, basically. And then when find and mark returns a bingo, then winning boards, or that board will be put on the winning board, but only if it wasn't there already. Just make sure that the winning board is only being put on this map once. So even if you continue with the last thing there, if you continue doing this, because of these find and mark things, it used to be mutable, so it would always perform some mutations on this board with a number. And that we circumvented by only doing find and mark when not frozen. And then if it is frozen, well, then always return true. So you're already in a bingo, but at least we won't do anything. And what is it? The thing that we'll do, which we will do, is we'll just find this number. Find just tries to find this number across all of the rows, and then we'll mark that number. Oh boy. I just might have this sub since I just got a Fortnite ad before I could watch. I wonder if I can choose. So first of all, I'm really sorry, Mr. Rat, that you had to go through that. I wonder if I can choose which ads that Twitch can and cannot run or something like that. I really don't want to push Fortnite onto anyone, really. It's horrible. Jesus. Yeah, I'm gonna turn this thing into expression bodies. Same with this. So this is a little bit of cleanup. And then, yeah, we return bingo. I think I might get rid of this. This is just silly. We don't really see this thing anywhere. Can we inline type aliases? Oh, we can. Nice. So when do you have bingo? Well, when either your rows have bingo or the columns have, any of the columns have bingo. Freeze board when bingo. This is basically when bingo happens, then also freeze the board. And of course, this mutation also doesn't happen because the moment you're frozen, you don't get muted anymore. And then this is just at the higher order function that we basically wrap the execution of that block in a guard clause to only do that when you're not frozen. Yeah, and then there's just a bunch of stuff on finding a number. It's an early return here. And if nothing came out, then just return null. This is definitely also an expression body. And then we're going into the data types themselves. So just a row class takes in, yeah, here we've got some duplication though, huh? Because both column and row have the has bingo thing, which is implemented exactly the same. It's just that row has a get unmarked thing. Maybe, you know what? Doesn't really matter, huh? And then a markable number is just a thing, a number that can be marked. That's it. All right, I am going to commit this as the Salt Day 4 Part 2. $130. Okay, let's read the challenge of today. You come across a field of hydrothermal vents. That sounds cool. These vents constantly produce large opaque clouds, so it would be best to avoid them if possible. They tend to form in lines. The submarine helpfully produces a list of nearby lines of vents for you to review. Each line of vents is given as a line segment in the form of one position to another position. Okay. These line segments include the points at both ends. In other words, an entry like 1, 1 to 1, 3 covers points 1. Yeah, okay. Only consider horizontal and vertical lines. Lines where either x equals 1 or this one equals x2 or y2. And so not all of these are horizontal or vertical lines. Each position is shown as the number of lines which cover that point. Yeah, so you sort of overlay them. If no line covers that point, there's a dot, and if multiple lines cover that point, it will have the number of how many lines cover it. So I guess here there's one line that goes from 0 to 6, I guess. No, to 5. And then another one that goes from 0 to 3, or to 2, I mean. Top left pair of ones. Yeah, voila. To avoid the most dangerous seas, you need to determine the number of points where at least 2 lines overlap. In the above example, this is anywhere in the diagram with a 2 or larger, a total of 5 points. Consider only horizontal and vertical lines. At how many points do at least 2 lines overlap? I feel like I will be working on this problem for the entire day or something like that. Huh? Oh yeah. Or maybe, maybe there is there's some math you can do. That means me Googling, learning new math stuff. It's also fun, I guess. And now we only have to take into account horizontal and vertical lines. I feel like it's not even it's a limitation that you might not want to have even. Can we cheat our way around this maybe? Yes, out. Can we cheat our way around this? Yeah, maybe we can make ranges or something. And then do grouping or something, maybe if we can do that. What's the actual return thing? At how many points? You need the points. There's some associated by magic I feel like we can apply there. Oh, okay, let me tell you what, I'm gonna... I'm going to stop the stream here and then maybe restart it and see where we can go, because yeah, it'll just save me some nice admin that way I don't have to cut videos or whatever. Okay, so we will be right back as I go offline, but be right back. The stream will be back online real soon. Then I'll just have 2 videos.